On the structure of the strain gauge, we can divide the strain gauge into two classes, unbounded and bounded. In unbounded strain gauge, we present a good example of these types here, these types here. A pressure strain gauge sensor. As you can see, we use 4 strain gauges. Strain gauge A, B, C, and D are 4 strain gauges of this sensor. Unbounded means we have a wire placed between 2 points, and other parts of this wire are unbounded, and only these 2 points are in our hands to strain or to compress. Okay. Let us discuss about this sensor. We have 4 strain gauges. A strain gauge A and a strain gauge D are similar, and a strain gauge B and C are similar together. Let me start from the beginning. We designed this sensor to measure blood pressure using a catheter. We connect this part using a catheter to the vessel, and the pressure of the blood will be transferred from this catheter to this point, and the liquid, a solid liquid inside this catheter, will transfer the pressure to this diaphragm. Therefore, if the pressure of the blood push the diaphragm from the left to right, this bar will transfer the pressure to the moving part of this sensor. We have a backing here which is fixed, and a moving part here. I only mark the output of the fixed part of the sensor with red corners, and the moving part with another color. Maybe this is good. As you can see here, we have a part of sensor which can move inside this fixed part. Okay, we have a part here which can move to left or right, but the external backing inside this these 4 red corner is fixed. Okay, now the forces are transferred from this axis, from this bar to the movable part of the sensor. And if the pressure from the blood push the diaphragm from left to right, this moving part will be moves from will move from the left to the right. Therefore, because of the fixed points of the strain gauge, as you can see, the length of the strain gauge A and D will be reduced because the movable part will move from the left to right, and the length of this catheter will be reduced. This strain gauge will be reduced. And also, the length of the strain gauge B and strain gauge C, because of the fixed points of these strain gauges, because of the moving from left to right, will be increased. The length of these strain gauges will be increased. Now we have 4 strain gauges with various behavior for a direction of the pressure. If the direction of the pressure is vice versa, the length of L1 will be increased and the length of L2 will be decreased. Now you have a strain gauge with 4 resistance, which we can utilize these 4 strain gauges in a bridge A, D, B, C. And using these strain gauges in a bridge structure leads to a high sensitive sensor. We use 4 strain gauge, 4 varying strain gauge in this structure to increase the sensitivity of the sensor. Therefore, this types of strain gauge is a good sensor to measure the low variation of pressure inside our vessels. In this slide, I emphasize the effect of the number of strain gauges. As you can see, if we use only one strain gauge, as we place it in a bridge, we will achieve a low sensitivity in our sensor, because the output voltage of this bridge are important for us. Therefore, we should increase the variation of this voltage because of a similar displacement. Let us to measure the voltage and the effect of the number of strain gages inside the bridge. In the first simple structure, as you can see, we have a fixed voltage here. The voltage here V1 and here V2. If we want to measure V2 minus V1 as the V voltage, in this one V is constant, and the variation of the resistance of the strain gauge will only increase in one step. As you can see, one increasing or decreasing in the voltage. For example, we apply a displacement on the strain gauge, and V2 increase because of the strain gauge impedance, resistance increase, and therefore the output voltage V2 will be increased too. But the second one, you can see we utilize two strain gauge. In the inverse action, as you can see, remember that A and D was similar and B and C was similar, but these two strain gauge strain gauge types in the previous slide were acting in different ways, or inverse action, inverse output. Therefore, assume that we use A here and B here, for example. Increasing of the resistance here and decreasing in resistance here will increase the V2 two times. Remember that V2 here is RB divided by RA plus RB. For example, this is VS. Increasing in R and RB and decreasing the RA will increase V2 two times. Therefore, the V2 will be double increase, but V1 is fixed and constant. Therefore, the output V is will be larger than the first structure. And if we use A, B, and also C and D in this structure, the output V will be double increase with V2, and as you can see here, because the V1 voltage is RD divided by RC plus RD Vs, and because of the similarity between RD and RA, and similarity between B and C decreasing in this. Therefore, the output voltage will be double decrease with double increase with double reduction of V1. And as you can see, 4 times of increasing are occur. Therefore, using a bridge with 4 string gauges are a good choice. Is a good choice for the high sensitive, for having a high sensitive pressure sensor.